Okay, I can see people's coming in. Good afternoon, everybody. Welcome to the session. My name is Qing. I'm the Inside Sales of a FluidTech Europe team. And today I will introduce Mr. Marius Grisaru. Sorry if I didn't say the name correctly, but today he's going to give us some more information about current transformer oil monitoring and practice. And now we can start the session.
I can speak now. You can see me now. Power transformer are not only a machine alternative reducing and increasing current and voltage. A transformer is filled with metal, inorganic material, semiconductor, other organic. In the special reactor, many energy types are present: electrical, magnetic, and kinetic energy translated into temperature. As for the human, also for the transformer, the oil sampling and transporter stage are crucial for having the correct appropriate final diagnosis. Here, it's also very important to avoid injuries to the sampling team and damage to the transformer due inadequate sampling procedure. 5 compulsory valves of any transformer are displayed here. From all of them, it's possible to obtain oil sampled. In some cases, one may find many more oil valves, and the technician should know exactly from where to obtain a sample. For each sample valve, different oil volumes should be considered. Next slide, please. Next slide, please. Next slide, please. You can move to the next slide, please. Yes. Transformer oil quality is compromised between opposite properties. Mineral insulating oils are produced with many contradictories as electrical properties and oxidation stability, high refining degree, meaning low stability, and good insulation properties. Additives are the solution enough, although electrical engineers prefer non-inhibited oils. Next slide, please. Non-mineral insulating liquids are manufactured from silicon or vegetable resources. They are quite different liquids. We not call them oil at all than mineral oils with different properties, beneficiary, and also some of them are problematic for power transformers. The user should select the liquids or the oil accordingly to the specification of the transformer. Trends for transformer power in MVA and voltage versus year of manufacture. Of course, the need of high electricity amounts to be transported over longer distance has imposed a higher power expressed in the MVA and higher kV level. Consequently, the size of transformer increased exponentially both in power voltage, although there are considerable progress in reducing magnetic core loss or on-load causes and transformer cooling. The transformer produces much more heat. The heat loosens the insulating property of the insulating matrix, reducing the conductivity and the insulating properties of the oil and accelerating the aging of all the materials inside the power transformer. The elevated temperature also promotes the potential occurrence. In this slide, we may see a report released by Dr. Mladen Banovic from Transformer magazine. Problems in the transformer operation. Overall leakage is causing a significant amount of oil waste and the second highest financial damage worldwide in last 10 years. Here we see the transformer start to operate as a certain insulating safety margin. This depends on the transformer design, transformer manufacturing process, and preparing before energizing. Stress as heat and moisture may get closer to the actual insulation level to critical level. Stresses of all oil kinds, internal and external, and even extraterrestrial stresses may challenge the transformer operation. Sandstorms are one of the industrial concerns for power transformers, and accidents already occurred in North America a few years ago. Therefore, we need to preserve insulating properties as far possible from critical levels. Periodically test and adequate oil treatment are the key factor for prolonging transformer life and deep clearance of the insulation level from critical one. Oil treatment may avoid fires. Fire safety measure concern from many other aspects. Oil treatment may improve the transformer life and prolong it. What happened to what caused the transformers failure or aging or aging before time normal lifetime of the power transformers that is normally more than 50%. These are energy, water, and air. Here we can see also what happened with the transformer, how the oil is degraded. First of all, the color is changed. after this antioxidant concentration decrease and oil acidity and other polar components appear, and in the transformer as oil acidity, and the inhibitor concentration is are lower. This is a test of the routine oil test according to IEC standard with the limit and test frequencies. Both limits and frequencies should be adapted to transformer specification. Here, those are the relevant IEC standards for test and limits values for new oil and surface oil. Of course, there are different values for different equipment type. All the parameters and the limits are described and classified according to the limits. Same as for American International Standard, ASTM and IEEE. Users should be aware that oils manufactured according to IEC and ASTM are different, and those tests are different. Most of the laboratories in the world perform the test only according to IEC or ASTM, not for both. Here are some examples of special tests that we perform for insulating oils. This is dissipation factor. The dissipation factor represents the loose polarization for the oil. And here we have a video that show how to perform dissipation factor and what are the main issues for performing. We see that a cell is first of all it was flashed. The operator feel the oil that should be measured again. If the oil before was contaminated with a high dissipation factor, then the flashing is maybe double, and now it was measured. Intervention test is one of the tests that we perform as a routine test for insulating oils. Here is an old device, so this device is a historic one, and we can observe here what we measured. We measure the interfacial test between the oil and water. As oil is more contaminated by polar impurities, the force is lower. So and the measurement is low. Here it's a very important difference between the IEC and the ASTM, and we see that it's make a change. For for insulating oil, we prefer to test acidity by color change, not by electrode method. It's more accurate and is more and most of the laboratory in the world adopt this method. Even it's time consuming, but is more accurate. Here we see the titration itself when by this small syringe, basic normally KOH, it's added to oil. Now we can see the main issue for measuring water in oil for power transformer is the fact we don't measure the water correctly, because we measure the water in the oil which contain only 1% of the oil. And one of the problematic issues with this measurement is because it's a very low, it's a very sensitive measurement. Many round robins around the world can observe a difference among the laboratories, and we are interested to know the water in the paper, not the water in the oil. And we sometimes with this curve for equilibrium, which are correct only for a new paper and a new oil, and the using of those curves for other type of oil, for aging oil and aging cellulose is not correct. So we don't know the most important parameter is the transformer, how much the paper, the cellulose contain water. It's very important to, this is why the Carl Fisher method that appear in the standard that most of the laboratories perform is not a correct method, and in this day, probably in the next future, other method will appear to measure the water in oil, in transformer, not by online methods. Here we can see how this, what is the difference at a low temperature. Most of the water is stored in the cellulose. When the temperature is it's increased, the water migrate to the oil. The main problem that is not shown here that it's a gradient of temperature in normal operation transformer. One of the solutions that appeared in last Segre brochure and also described by Dr. Oleg Roizman, it's a hysteresis, because the absorption and desorption of the oil in the paper is not similar by the angle of this hysteresis. There are theories that may calculate and make assessment of how many liters of water contain a transformer. And according to this assessment, we may perform oil treatment to remove the water, which is very dangerous to operation of transformers. There are many methods for removing the water from transformers. Each of the methods should be applied correctly according to the transformer, according to the quantity of the water, and of course the budget of the users. And we from most simple one as molecular sieve until a low frequency heating, which is very sophisticated and delicate method that need to be applied only by very skilled and experienced people, and some methods, some machines that are not know exactly how to apply it make more damage to the transformer than to dehydrate it. Corrosive sulfur, it's one of the main causes of failure in transformer, especially for modern transformer all over the world, and especially for highest power transformer, which are normally more expensive. And we need to check to know how which method to apply to remove these properties that may affect the transformer. Here there are two pictures of this black deposit. One of most popular methods to treat sulfur corrosion, potential sulfur corrosion, is to passivate the oil with a passivator. But this method is although it's very cheap, it needs to be monitoring and treated. Another method is to treat the oil. Replacing the oil for transformer is not a case. So please take care for your transformers. This is a picture and normal that was published yesterday about a deadly failure in transformer in Africa. I wish to invite you to Transformer Academy course for DGA. I don't mention here the most important test for power transformer, which is a DGA. And also we have a Transformer Academy course for oil test. And if you have any question or suggestion, I will be glad to hear and discuss with as many people. Thank you very much for the organizer and the participant for this important conference. Any question? I will.
Yes, we have some questions at Q&A section. Here I opening up on my.
Yes, I also read them. We have inline sensor, but not for antioxidant. For water, there are a lot of sensors. Not all are successful. For acidity, not. We don't have. It's any correlation between the BD breakdown voltage and IFT. No, it's not any correlation between breakdown voltage and IFT. IFT and DDF are correlated. If the water is 200 ppm insulating oil, how much water expect in cellulose? In mineral oil, 200 ppm is impossible number. The maximum content of the water in mineral oil, it can be 50 or 60 ppm, and then the cellulose is supposed to be also at the end of the life. 200 ppm for non-mineral oils, it can be, or silicone, esters or silicone. For them, it's another story, depending on the oil and the type of the paper, of the cellulose. The acidity increased, but IFT and BDV are okay. BDV is not correlated with acidity, as mentioned before. IFT should be correlated with acidity, and it's something that it's not logic that that IFT is not affected by acidity. IFT is more sensitive than acidity, and first IFT is changed, then acidity. In this case, it may be a contamination from another source, not a normal degradation of the oil. It is a possibility. So it is a possibility that acidity increase. This means a contamination, only a contamination. Why corona is danger? Why which DGA gas is more dangerous? Of course, a DGA more dangerous gas is for acetylene, not in the tape changer, in a on-load tape changer. Where acetylene is not the more dangerous, but in all other is dangerous. For example, if you have a bushing filled with oil, then the hydrogen is more. It's depending. Corona is danger. It can be a problem. GTL. If a GTL is connected to sulfur corrosion. Until now, it's remaining, the sulfur corrosion issue is not clarified 100%. And one of the theories that can be real, it says the oil, GTL, and other type of oil which not contain sulfur itself may dissolve sulfur from other part of transformer as glue or member or glue or paints. They are inside of the transformer, and there are some literature that mentions that sulfur may increase in transformers even if the oil itself not contains sulfur from the beginning. It's always good to measure. These cases are rare, but it's always good to measure even if you don't have in the beginning, in the oil, in the initial oil sulfur. What are the limits for fluorine oil for paper breakdown? This is a very good question that we don't know exactly the answer. The normal value it's 100 ppb, which is mean 0.1 ppm. But it's not always correct. A few years ago, I published together with Michel Duval and other researchers cases where we may have very high values of furans, and the transformer are still operating. You should consult an expert for this question, which is very good, and it's not really answered until now, and probably will remain like TGA, something that we'll never know. What is the best reference book for interpretation of transformer oil recommended? This also a very good question, because there are a lot of books. I would recommend to read Sigre brochures, and of course latest book for Dr. Narasim that is published by Transformer Academy, and you may find it also in Transformer magazine. This is the latest and include most of the all the data that is available until last year, and it was revised by many, and by many good experts around the world. It's very yes. I don't. Other way, you can if you wish to know more about this book, you can attend. I think there are free course for transformer oil. There are free course as a Transformer Academy. You may attend it. They are not cost. They are you can attend it for free. It was last year. I don't know now exactly. If the DDF only is high, yes, it's possible. This is one of the cases. The DDF is high and all other are low. It means that you contaminate the oil with some metals or some polars that you don't see. It is a case. Then you need to reclaim the oil, not to clean it, not to vacuum, only to reclaim it. It can be, it's not so dangerous, but we need to know the power of the transformer and the kV to see if they are important. Training webinars, as I may recommend, as I mentioned before, you may enter to Transformer Academy site, and there are a lot of web of seminars. Some of them are free, some of them are in the package, somehow. I have two there with the DGA and the oil test. Dr. Narasim have oil test, and there are others that are also free. There are differences between oil, between experts. We are a lot of experts around. We are some experts in the world that discuss all the results, and we not agree in many issues. But the standards and the brochure of Sigre are consensus of those. You may read the standards, IEC, IEEE, ASTM, and there you may find, actually they are not so modern, because a lot of things are changing since the standard was published. Okay, thank you. I see no more questions. There. See, we can sample in aluminum bottle for DGA. No, not only syringe is recommended. Aluminum bottle is also okay. It's allowed by the standards. The only thing you need to know how to take the sample correctly. For syringe is more complicated to take the sample correctly. For aluminum bottle is more simple, but you still need to know how to do it. Thank you. Thank you. Thank you to all, and bye-bye.